Hello everyone, how's everyone doing today? So today it's day one, it's Monday, April 27th. Today's lecture it's focusing on continue on quantum mechanics theory and build on what we learned last class, which is on filling electron configurations. So before we started, I thought I would start off the day by talking about the importance of learning. So I know everyone is like learning online right now, and the situation is not ideal. I mean, like you are having, just you're stuck at home, and you have to adapt to different styles your teachers provide you through online learning. So it's challenging for everybody, but everybody is capable of learning, right? So I want to talk about like your when you were a baby, your brain is actually born with so many cells, way more than your adult brain, and those cells are all capable of developing into something amazing. So the brain cells here you see on this picture, they are called neurons, and they are basically brain cells. And whenever when you're learning anything new, different cells, the different brain cells, these neuron cells start to make connections, and the connection they make is called synapse, and it's a special connection between neurons. And that's how learning happens, when one cell can communicate with each other and they can pass through signals. So for example, when you are learning piano every day, you're practicing, your fingers are practicing, your music cells in your brain is starting to make more and more connections, and that's how you learn how you be a better pianist. Okay, and if you stop using these cells, let's say if you never learn piano, and those cells will start eventually to die off, because like I said, you were born with way more than enough cells you need. So if you don't use them, you lose them. And so that's why, I think I mentioned it before, it's so important when you're young, you should be, learn as much as you can, because right now your brains are having like an overabundance of cells, and they are all capable of making lots of connection. And if you don't make those connections, you're going to lose them. And for a teenager's brain, so basically your brain is immature, you're still growing and learning, your brain is still making lots and lots connection, and a brain won't finish developed and won't be mature until at least 25 for a young adult. So you guys still have lots and lots of years to make yourself a smarter person. So if you think, oh, I'm not good at computer, that is what is known as a fixed mindset. Your brain is capable to learn. You can be a better person. You can be a tech person if you set your mind to it, if you keep learning. So I encourage you guys, when you're at home, other than learning your academics, just keep learning. Learn anything that interests you. Don't get so distracted into the gaming world. I know it's very addicted, okay? Spend some time, allot yourself some time to play each day, but also keep learning, because learning is so important, because you want to be a better person, a smarter person, and the only way to do that is, by yourself. You got to keep learning. Okay, so a little bit sidetracked, but that's what I want to deliver that message to you. So let's get back to the quantum mechanics theory. So last day I introduced this theory. So remember we talked about, now you need to when you think about atom, you don't think of it as two-dimensional. You don't think of it as only having rings, orbits, having electrons going around those orbits, but instead you need to think three-dimensionals. Okay, a three-dimensional space, and we call them orbitals. Orbitals are three-dimensional space where it has the highest probability based on these, really complicated equations calculated by Schrödinger, and he found out that it is these regions that you can find the, the electrons. That's where the you can it has the highest probability of locating the electrons. And remember, we talked about different types of orbits, right? Orbitals. So one of the pages on your notebook, you should have this. You don't have to print it all, right? So there are some pilots don't fly, 4 types of orbitals. So the s orbitals are like a spherical shape. The p orbitals are these double lobes, and there are 3 of them: px, py, pz. And when they're combined, they look like a little very nice flower. So again, you need to be able to visualize it. This is a 3-dimensional space. And the d orbitals, there are 5 of them, okay? And when they combine all together, it looks like this, okay? So again, what the heck this is? This is just a region of space where electrons are most likely to be found. You cannot pinpoint exactly, oh, I think the electron will stay right there. They don't stay there, but they're just going crazy, like in this region of space when they're excited, and they're not fixed at one point, but rather they can be found in this region of space. Okay, so there are 5 d orbitals here, and combined it looks like this. And for the f orbitals, which is a much higher energy level, there are 7 of them. Okay, so again, you have this page on the class notebook. You don't have to print it off. Okay, so there are 7 of them. You don't need to memorize them, but you just have an idea how they look like. Okay, so again, for the s orbitals, if you look at them, they just start off with the lowest energy level. It looks like a very tiny sphere, but at a much higher energy level, it's a much bigger sphere. That's how it looks like. Okay, now the p orbitals, so they look pretty much similar, okay, but again, you don't need to know these shapes, but generally p orbitals are double lobes, that px, py, and pz, right, at the second energy level. And the d orbitals, there are 5 of them, and they start off at the 3rd energy level. Okay, so these are the orbitals. Again, regions of space. That's it, just region of space where electrons can be found. Okay, so you should be able, I do expect you guys to be able to know at least the shape of the s orbitals and the p orbitals. So for today's handout, I gave you this page, which is this little tiny flower shape, and also the energy diagram that looks like this. So you should have these 2 pages ready before today's class. So I just want to again compare this newest model called the quantum mechanics model to the Ford's model you guys learned back in grade 10. So in grade 10, the sodium, for example, it has 11 electrons. So when you draw the Ford diagram, it looks like this, right? So you have 2 electrons in the first shell, 8 electrons on the second shell, and 1 electrons on the last shell. So this one is known as the valence electron. That's the electron that will interact in a chemical reaction. And now for the newest model, sometimes you heard this name called the wave model, because they believe that electrons are travel in waves. So instead of, sometimes they call quantum mechanics model or the wave model. So for this, again, I know it's it's kind of weird to draw, but I think you guys can draw it. So imagine the nucleus is right inside the center, right, very small, and you can imagine there's the first orbital right here. That's the 1s orbital. Okay, so that's where this line is. That's the 1s orbital, right? And then the 1s after that will be the 2s. 2s orbital, again, it's not a ring. I'm just drawing the different colors here, but that's the region of space. It's a spherical shape right outside of the 1s. So that's the 2s. Okay, so the blue color here, that's the 2s orbital, and they're overlapping. And then for sodium, we also need the the p orbital. So we have the px, doesn't matter where they're oriented, px, py, and pz. Okay, so they're all overlapping, looks like a little flower like this. Okay, and again 11 electrons. So remember, like last day's homework, I asked you guys to fill this in on lines like this. So if I have 11 electrons, 1s would hold 2 electrons, 1s2, and second, the 2s orbital maximum holds 2, so that's 2s, 2. Now, so that's, I have 4, so I have 7 left. So for the hang on, no, 7, right? So for the px, py, pz, so remember you have to fill in 1 each first, right? Just like a, they go into an empty seat first before they pair up, like so. Okay, to reduce repulsion between electrons. And then so that's 10 electrons, and the last one, you fill it in the 3s orbital. Okay, so here for the last one here, you do need the 3s orbital, which is the larger spherical shape that's right outside of the 1s and 2s. Okay, so that's this region right here. So this is there are different ways to represent this model, right? So I just want to draw it, like drawing this board model. I just want to have you imagine drawing it in this complicated flower picture. So I'm going to fill in 2 electrons in the 1s orbital. So just like the first ring has 2 electrons here, I can fill in 2 electrons here. Okay, exactly where they are, you don't know. Okay, and 2s maximum holds 2, so somewhere here. And px, py, pz, each one of them can hold 2. So I put 2 here, 2 here, and 2 here. Okay, and also lastly, my valence electrons on the 3s, which is right here, can be anywhere. I don't have to draw here, I can erase it and put it right here. Okay, so those electrons can be found in that big region of space. Okay, so this is the newest model compared to the Bohr model. I just want you guys to compare. They have their similarity. Again, the valence electrons here is also 1. Okay, so this is the valence electrons. That's the electrons that's reactive. Okay, so that's the valence electron right here. Okay, so that's what we learned last day. I just want to make it clear to you how you compare it. And before we ended last day, I also asked you guys to draw the condensed way, because you don't want to draw these arrows all the time. So it's 1s2, right? 2 arrows, 2 electrons on in the first orbital, 2s2, and then the p's, you combine them all, x, y, z, and there are 6 of them, and then 3s1. Okay, so this is called the condensed electron configuration. But I do expect you should be able to either draw the arrows or do the condensed way. But today I will actually show you something even shorter to make your life a little bit easier. Okay, now before we get into that, a couple more things I want to show you, which is I need you to also to know, like, these orbitals, these lines here, they are not like flat, right? But as you can see, they are like the lowest energy level is 1s. So the better way of drawing those arrow diagram is using this picture here. So this is the energy level diagram for multi electrons, atoms with multi electrons. So just you have to imagine the nucleus is somewhere down here. Okay, so the lowest energy level is the 1s right here. This is the lowest energy level, and as we go up, and we have the highest energy level. And I want to make sure you have your periodic table with you as well. The periodic table is actually arranged in energy levels, as you should remember, like shells, right? This is energy level 1 and 2 and 3 and 4 and so on, okay, all the way to 7. Okay, so that's the last energy level, and it should be all completed here. Okay, 7 energy levels. And so it corresponding to this energy diagram here, like we have the really high energy level on the top. Okay, so again, let's try to fill in the sodium 11 electrons on this diagram, and start off with 1s2, right? That's lowest energy orbitals, and then fill in 2s, that's the next lowest energy level orbitals, and then we have the 2p's. 2p, the energy is slightly higher than, let's see, I should be doing this way. Remember, we have to do single before we pair them up. Okay, so 2px, 2py, 2pz. Okay, so that goes 10 electrons, and our valence electrons, and it's on the 3s, like this. Okay, so this is sodium. This is the energy level diagram for sodium, and that's how, instead of drawing this way, we usually put it like this, so it's easier to see and easier to draw. But theoretically, the real case is the energy level. You should be able to see that it's one higher than the other. Okay, and just gonna stop here. All right, so let's resume here. I was just taking a quick break. So hopefully you printed off the sheet and just draw on it using pencil, because I do expect you to be able to keep using the sheet and draw different electron configurations using the sheet. So one thing I want you guys to take a look is the different energy levels, and also the different orbitals. So we talked about the 1s is the lowest, and then the 2s, and then the 2p's, and the 3s and 3p. So now notice here, something interesting is happening here. The next lowest energy level after 3p is actually 4s. Okay, so the d orbitals, there are 5 of them. When there are all these lines, that indicates there are 5 of them. They are actually slightly higher in energy level than the 4s. Okay, so it's just for a fact that these energy levels are slightly higher than 4s. And then after the 3d, and it goes into 4p's. Okay, and if you can take a look at here, 5s and then 4d's, just keep on building on from the previous one, and then 5p's. Now after the 6s orbitals, there's the f orbitals. Okay, so 7 lines here to indicate that there are 7 different f orbitals. I do not expect you guys to fill in electrons into the f orbitals. Now, I know this looks, however, like how do I ever remember these energy levels? I'm going to show you something that's super duper easy for you to know these energy levels, and that is, again, your best friend in chemistry, right? So your periodic table. So how do you know, where the orbitals are? In fact, they are right in front of you. Okay, so for example, here I'm just going to so having helium here, I'm just going to draw it right here. I'm just going to move helium there. So for these two families, they are actually occupying the s orbitals. So for example, I'm just going to label here s orbitals. Okay, so for example, hydrogen is 1s1 because it only has one electrons, right? So you only use the 1s orbital. And helium, for example, it's 1s2, so it's full, it's completed. Okay, and then I want to let's say, for example, these guys here on the right hand side, and they are using the p orbitals. Okay, so the p orbitals actually doesn't start until like 2p, right? So these are the 2p and 3p's and so on, all the way to 7p's. Okay, do you guys can see it here? So you see here these columns here, they're occupying the p orbitals. And if you count the number of electrons, you know, the total number of electrons that it can fill here, they are 6. The p orbitals can hold maximum 6 electrons. Okay, so for example, the way that you can think of this as, let's say, let's do carbon. Okay, so that's something that we did last day. Carbon has 6 electrons, so you just basically go from here, 1s2, use up the 1s orbital, and then 2s2, these are the 2s2 orbitals, and then you just need 2p, 2, 1, 2. Okay, so that's the electron configuration for the carbon. And then, so we have, it's getting messy here, we have the 3s, and all these are the 3p's, 4s, and here, that's where the d orbitals begin. But you have to remember that it actually starts with 3d, okay? So all the 3d orbitals are in the middle here. These are the 3d orbitals, and it can maximum hold 10 electrons. So if you count from here all the way 1 all the way, this is 10. It can maximum hold 10 electrons, okay? So we have the 4s, and then the 3d, and then here it goes to 4p. So don't draw like me, because that will make your periodic table really ugly. But I will have show you a page where it's on your notebook as well. So we have the 5s, and then after 3d, these are the 4ds. After 4d, these are the 5p's. Okay, do you guys see where how this can let you know the location of the orbitals? So this is the summary here. Okay, so that's just quickly summarize what we just talked about. We have the 1s, 2s, 2p, and then the d's starts right after 4s. Okay, and then 4p, 5s, 4d, and the f orbitals, they actually begins right here. Okay, after the 6s. So basically the order is 6s, and then 4f, and then 5d, and then 6p. And if you go back to this energy diagram, that's exactly what it shows you. Okay, so it's actually no need to memorize everything, because you have your best friend right in front of you. I don't like that being that messy, but you can just simply label these one as the s orbitals, and the 3d's begins right here, and the p's, these are the p's, and then the f orbitals right here, the 4f begins right here. Okay, so actually let's do the this is the 4f, and this is the 5f, but you don't need to know them. Okay, but just want you to know that's where they begin. So 4f goes here, and then 5f goes to the next one. Okay, so that's the, now you have that. I'm going to show you guys how you can do electron configuration really quickly just by looking at the periodic table. But I want to go back to your homework last day, which is on this package here. We're not done, but we remember this on page 6, on page 4. You should have all these filled out, but I only did some of it. I want to do maybe just one more with you. So calcium, let's do the, if you have done it, just kind of follow me along. Just wait for me. You should have it all done. So calcium, it's 20 electrons, right? So we have 1s2, 2s2, and then the 2p's, they are all filled. So all these are inner orbitals. 3s2, 4p, 6. So all of those would give you how many? 6. That's 10 plus, that's 18. So I have 2 more, right? So calcium also have the 4s orbitals filled as well. Okay, so calcium, that's the electron configuration. So you guys can pause here and double check your arrow diagrams, and also the condensed electron configuration. And now, after what I just taught you about using the location of the periodic table, you can actually do this in a much faster rate. Okay, that's what I'm going to show you next. But for now, just pause it here and double check your answers. Okay. So for today, we're just gonna have you guys do a couple more practices on electron configuration, and I'm going to show you something called the chord notation, which will help you to shorten the electron configuration. But because as you can see, like for this one, calcium, it gets long, right? And you don't want to like keep writing all the way to the 7th orbital. Okay, so now just want to teach you guys the quick way of just telling yourself what the electron configuration is for any of the the, the elements on the periodic table. So for example, I'm just going to randomly pick one, and then we are going to just talk. We're just going to talk about the electron configuration verbally. Okay, just say it out loud. Okay, so can you guys do it with me? So let's say we are doing let's say copper. Okay, so let's do the electron configuration for copper. So you know, before today you will be just like, oh, I have 29 electrons. I have to kind of, you know, follow the arrow diagrams and go from filling them in one by one, make sure I got it right. But now, instead of, you know, doing that, you can just look at your periodic table, look at the location here, and we can say it out loud. Say out loud the electron configuration. Okay, so let's start from the beginning, the lowest energy level. So the lowest energy level you need to fill in is 1s2. Okay, so fill in 1s2, and then 2s2, 2p6, 3s2, 3p6, 4s2. You're right here on the 4th energy level. Now start the D's. The D starts right here all the way to this location. So remember we talked about here, this is like 1 electron and this is 10. That's when all the d orbitals are all filled. So basically copper, it's just all the way to it's 1 to the 9th electron. Okay, so it's 3d9. Okay, so do you see how I get this electron configuration? So I can just once again 1s2, so you can write it down now. 2s2 right here, 3 not 3 yet, 2p6, that's when it's all filled. 3s2, 3p6, and then 4s2, and then lastly these valence ones, 3d9. Okay, so that's the electron configuration for copper. See how easy that is, right? So let's do one more. If you just in case if you didn't follow me with this one, I'm just gonna erase all these. So let's do how about let's do strontium. Okay, draw strontium right here. Okay, strontium 38 electrons, but we don't need to count them. We just follow the order of the electron, the orbitals, and we know we'll account for all of them. Okay, so strontium, let's start with the lowest energy level, 1s2. Okay, 1s2, 2s2, and 2p2 right here. 3s2, 3p6. Did I say 2p6? Yeah, it's all 6. Okay, so and then 4s2. Now these are the d orbitals. 3d starts right here. Okay, 3d starts right here. So all the d orbitals are filled. So 3d10 all the way to here, and then 4. Okay, so 4p. Remember this is 4. This is 4p. So 4p6. Okay, now the valence electrons are here. It's 4s2, strontium. Okay, so that's how you do electron configuration from now on, just by looking at your best friend. So for today, I just want you guys to complete this table here. I haven't done any of these ones with you, but we did the calcium one. Okay, well, I'm just going to show you guys how to do the the chord notation here. So you know what, let's just do the easy one, carbon. So I'm just going to copy this here, carbon, it's 1s2. You guys need to write the protons, neutrons, and electrons here. I'm not going to repeat that. You should know how to do that already. 2p2. So for the chord notation, it's a short way of writing electron configuration. And for chord notation, it's by using the noble gas. Okay, we're gonna put the noble gas as the chord, and then all the valence electrons right outside of the noble gas. So how you're gonna do this one is, for example, for carbon, if you take a look at the position of carbon on the periodic table, carbon is right here. So what you're going to do is, carbon is on the second energy level right here. You're going to use the noble gas that's right above it. So in carbon's case, you're going to use helium. Okay, so helium, you are going to put it in a square bracket. So like so, helium square bracket. So basically that replaces 1s2. Okay, and then you're going to put the valence electrons 2s2, 2p2 on right after it. As you can see, for carbon, it doesn't really shorten anything, but for others, it will. So I already did calcium with you right here. So I'm just going to copy this part here from calcium, and then we do the chord notation. So again, calcium is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Okay, so again, for calcium, you're going to look for the noble gas right above it. So calcium is on the fourth energy level here. You are going to be picking argon. Okay, so it's the one right above it. So for this one, basically, put argon in a square bracket like so. So basically that replaces all of these electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6. So that is the electron configuration for argon. Put it in square bracket, and you just put the valence electron right outside. Okay, so you see how much shorter that this is, right? This whole thing is argon. Okay, so don't write it like me, because you're going to take away the other space. But I just want to show you that whole, this long electron configuration. You replace that by using argon in a square bracket. Okay, so that is it. So I want you guys to finish everything on this page. This is boron, B with 5 electrons, protons is boron. And then practice the chord notation. And if you can do these ones, you can do any of them. You can randomly, if you need more exercise, just randomly pick any elements from the periodic table, and you should be able to say the electron configuration, verbally. Okay, and I want you guys to, pick a few of them also to practice how to draw arrow diagrams like this. Okay, use a pencil, and you can erase it, once you're done. Okay, so that's the homework for today. I hope you guys are getting the hang of filling electrons. I don't think they are hard. They are very similar in a way to how you draw the board diagrams in a ring, but now it's more sophisticated, and it's broken down into more energy levels and different. They call it, sometimes use subshell. So the big the whole orbital, like p orbitals, they call it like just shell, and then the individual one, px, py, pz, you will heard of the term called subshells. So that they are all the level, like orbitals, are they broken down into subshells. So like the d orbitals, there are 5 of them, so there are 5 subshells. You will see those terminologies in the Hamptons textbook as well. So, you know, if you want more exercise, go to the Hamptons. I don't think there are a lot of exercise over there, but like I said, if you can do these these ones, you should be able to do any of them. Okay, so we'll stop here. We'll go over the answer keys next day, and then next class we'll start talking about electron configuration for ions. Okay, if you want, you can read ahead. Otherwise, I'll see you on Wednesday's lecture. We'll talk about we'll finish most of this package on electron electron configuration for ions. And then I'm thinking Friday I will have a live lecture with you guys as well, so that we can you know, have some live questions. I will practice some other stuff with you guys. Maybe we'll, you know, just, yeah, we'll see. um, I'm, like, today is a Saturday. I'm just thinking ahead, but I don't really have a solid plan yet. Anyway, so I hope you guys enjoy and understand today's lecture. I will talk to you soon. Bye.